Every star you see in the night sky has a life story. It was born, it grew up, it changes over time, and one day it will die. Some stars fade away quietly, like a campfire slowly going out. Others die in a gigantic explosion called a supernova, brighter than a whole galaxy for a short time. In this video, we'll follow the life of a star from a baby star to an adult star to its final boom. And you'll see how that story is also our story, because the stuff inside us was once inside stars. Stars are born in huge space nurseries called nebulas. A nebula is a massive cloud of gas and dust floating in space, often shaped in wild, beautiful forms. Most of the gas is hydrogen, the main fuel stars use. There's also helium and tiny bits of heavier stuff like carbon and oxygen. Nebulas can be dozens or even hundreds of light years across and can hold enough material to make thousands of stars. They can look so colorful in photos because of glowing gas and dust lit up by nearby stars. A nebula can hang around quietly for millions of years, but if something disturbs it, things change. A nearby supernova can send a shock wave through the cloud, or parts of the cloud can slowly bump and mix. In some spots the gas gets a little denser. Gravity is stronger in those dense spots, so they start pulling in even more gas. The more gas they pull in, the denser they get. This snowball effect makes clumps shrink, heat up, and spin faster, like a skater pulling in their arms. Each collapsing clump is the beginning of a new star, and sometimes a whole group of stars is born together in the same region. As the cloud core collapses, it turns into a spinning disk of gas with a hot ball in the middle. That hot ball is called a protostar, basically a baby star still under construction. The disk around it is called a protoplanetary disk, and later it can form planets, moons, and asteroids. Gas from the disk keeps falling onto the protostar, making it bigger and heavier. Gravity is squeezing it, so the center gets hotter and hotter. At this stage, the protostar might blow out narrow jets of gas from its poles, like little space fountains. From far away, dust may hide the protostar, invisible light, so we study many of them with infrared and radio telescopes. Deep inside, temperature and pressure in the core are rising. When the core gets to around 10 million degrees, hydrogen atoms start to fuse together. That moment is when the baby star switches on for real. So, what happens once a star is born? It enters its long and stable adulthood, a phase we call the main sequence. Think of nuclear fusion as the star's engine. Deep inside the core, intense pressure and heat smash hydrogen atoms together to create helium. This process releases an enormous amount of energy, which we see as light and heat. This energy pushes outward, fighting against the relentless inward pull of gravity. When these two mighty forces find a perfect balance, the star becomes stable, shining steadily for billions of years. Our very own sun is a main sequence star right now. It's been burning brightly for about 4.5 billion years and has enough fuel to keep going for another 5 billion. But not all stars are the same. Smaller, cooler stars, called the red dwarfs, sip their fuel slowly and can live for trillions of years, way longer than the current age of the universe. On the other hand, massive, hot blue stars are the rock stars of the galaxy. They live fast, burn through their fuel in just a few million years, and go out with a bang. As stars settle into their main sequence adulthood, their color tells us a story. Cooler stars glow a gentle red, while the hottest stars blaze a brilliant white or blue. Astronomers organize all these stars on a special chart called the Hertzsprung-Russell diagram, which plots their brightness against their temperature. Most stars, including our sun, fall along a neat diagonal line on this chart, and that's the main sequence. Our sun sits right in the middle, a pretty average, but very important star. But nothing lasts forever. After billions of years, a star like our sun starts to run out of hydrogen fuel in its core. With less fusion pushing out, gravity begins to win, squeezing the core tighter and making it even hotter. This extra heat ignites the remaining hydrogen in a shell around the core, causing the star's outer layers to puff up dramatically. The star expands, cools, and turns red, becoming a red giant. It can grow so enormous it could swallow planets like Mercury and Venus. For stars much more massive than the Sun, this process is even more extreme. They swell into red supergiants, hundreds of times larger than our Sun, like the famous star Betelgeuse. Inside these giants, fusion continues, creating heavier and heavier elements in an onion-like structure, from helium to carbon, all the way to iron. So what happens at the very end? For a star like our Sun, the ending is relatively peaceful. After the red giant phase, the star sheds its outer layers, which drift away into space, creating a beautiful, glowing cloud of gas called a planetary nebula. What's left behind is the star's tiny, hot and incredibly dense core, a white dwarf. It's about the size of Earth, but contains half the mass of the Sun. This white dwarf no longer produces energy. It just slowly cools and fades over billions and billions of years, eventually becoming a cold, dark black dwarf. For massive stars, the final act is way more dramatic. In their cores, fusion doesn't just stop with helium. It keeps going, fusing helium into carbon, carbon into oxygen, oxygen into silicon, and so on, building heavier elements in layers, kind of like an onion. Eventually the core becomes mostly iron, and iron is a dead end for fusion, making it doesn't release energy, it actually uses energy. This means the core suddenly loses its power to fight gravity. Gravity wins, and the iron core collapses incredibly fast, in less than a second. The core gets squeezed so hard that protons and electrons mash together to form neutrons. The star's outer layers fall inward, smash into this new, super stiff neutron core, and then bounce back out in a colossal shockwave. This is the start of a core collapse supernova. A supernova is one of the most powerful events in the entire universe. For a little while, a single exploding star can outshine a whole galaxy of billions of stars. The shockwave blasts the star's outer layers into space at thousands of kilometers per second, sending a flood of tiny particles called neutrinos racing outward. During this epic explosion, many of the heaviest elements in the universe are created and scattered, things like gold, silver, and uranium. These elements mix into nearby clouds of gas. Later, those clouds can form new stars, new planets, and even life. The iron in your blood, the calcium in your bones, it all came from stars that went supernova. In a very real way, we are made from the ashes of dead stars. So what's left behind after the explosion? The core of the massive star remains. If the core isn't too huge, it becomes a neutron star. A neutron star is unbelievably dense, only about 20 kilometers wide, the size of a city, but with more mass than our Sun. A single teaspoon of it would weigh more than a mountain. Many of them spin super fast and shoot out beams of radiation. If those beams sweep past Earth, we see a blinking object called a pulsar. But if the original core was really massive, gravity crushes it even further into a black hole. A black hole is a spot where gravity is so strong that nothing, not even light, can escape. The story doesn't end there. The gas and heavy elements blown up by supernovae mix with the surrounding space. Over millions of years, gravity pulls this enriched material together to form new nebulas, the birthplaces of the next generation of stars and planets. Our own Sun is one of these later generation stars, so when you look up at the night sky, remember this incredible cycle. Stars are born, they live, and they die, sometimes gently, sometimes in a blaze of glory, and in their death, they provide the raw materials for new life. The atoms in your body were forged in the heart of a star and scattered across the galaxy. We are all, quite literally, made of star stuff. Thanks for watching. If you enjoyed this journey through the stars, don't forget to like and subscribe for more space adventures.